Today I will be explaining and demonstrating the concept of gravity to you.
Gravity is a natural phenomenon by which physical bodies attract each other with a force proportional to their masses, and inversely proportional to the square of the distance between them. It is most commonly experienced as an agent that gives weight to objects with mass and causes them to fall to the ground when dropped. The phenomenon of gravitation itself, however, is a byproduct of a more fundamental phenomenon described by general relativity, which suggests that space-time is curved according to the energy and momentum of whatever matter in reaction are present.
Good. Gravitation is one of the four fundamental interactions of nature, along with electromagnetism and nuclear strong force and weak force. In modern physics, the phenomenon of gravitation is most accurately described by the general theory of relativity by Einstein, in which the phenomenon itself is a consequence of the curvature of space-time governing the motion of inertial objects. The simpler Newton's law of universal gravitation provides an accurate approximation for most physical situations, including calculations as critical as spacecraft trajectory. The planetary body, including Earth, is surrounded by its own gravitational field, which exerts an attractive force on all objects. Assuming a spherically symmetrical planet, the strength of this field at any given point is proportional to the planetary body's mass and inversely proportional to the square of the distance from the center of the body. The strength of the gravitational field is numerically equal to the acceleration of objects under its influence, and its value at the Earth's surface, denoted g, is expressed below as the standard average. The Earth's standard acceleration due to gravity is 9.8 meters per second squared, or 32.2 feet per second squared.
This means that ignoring air resistance, an object falling freely near the Earth's surface increases its velocity by 9.8 meters per second for each second of its descent. Thus, an object starting from rest will attain a velocity of 9.8 meters per second after 1 second, approximately 19.62 meters per second after 2 seconds, and so on, adding 9.8 meters per second to each resulting velocity. Also, again, ignoring air resistance, any and all objects, when dropped from the same height, will hit the ground at the same time. Modern work on gravitational theory began with the work of Galileo in the late 16th, early 17th centuries, and his famous experiment dropping balls from the Tower of Pisa, and later with careful measurements of balls rolling down inclines. Galileo showed that gravitation accelerates all objects at the same time. This was a major departure from Aristotle's belief that heavier objects accelerate faster. Galileo correctly postulated air resistance as the reason the lighter objects may fall slower in an atmosphere. Galileo's work set the stage for the formulation of Newton's theory of gravitation.
I will now demonstrate the force of gravity, specifically Earth's gravity, acting on this object. As you can see, it pulls it towards the ground and accelerates at a rate of 9.8 meters per second. Galileo stated that two objects, regardless of mass, will accelerate at the ground at the same speed. And I will demonstrate that now. As you can see, even though that these objects have two different masses, they still accelerate towards the ground at the same rate.